Welcome to this e-lecture, which will be about probability distributions and normal distributions. And what are really probability distributions? Well, let's look at two examples. And let me also say that the probability distributions are based on frequency distributions for random variables, and they show how likely or probable it's that different values of one variable occurs. And we have two examples here. The first example is the so-called uniform distribution, where all outcomes are equally probable or likely. And that's when you throw one dice, getting the value of 1, 2, 3, 4, 5, or 6 are equally probable. But when you have a normal distribution, you have a symmetric distribution with a peak in the middle and fast sinking probabilities on each side of that peak. So it's most likely that you will get the middle value, and then high or low values are more rare. And let's look at an empirical example of a normal distribution. And our example is the height at examination for men liable for military service, and the mean in this distribution is 181 centimeters, and the range goes from the lowest to the highest, which is 158 to 202 centimeters, and the standard deviation is 7 centimeters. So let's talk a bit more about the standard deviation, because the standard deviation in a sampling distribution really indicates how much the sample means vary around the peak in a normal distribution, and the peak in normal distribution equals the population mean. So if we have a variable that we know is normally distributed in a population as such, and we have but we only investigate a sample from that population, the standard deviation says something about the mean in our sample, how much that varies around, or if we draw several samples from that population, the standard deviation will say something about how much the means in these different samples vary around the population mean. So it's really, the basic thing to know is that the standard deviation is a measure of statistical uncertainty or variation in the sample estimates of the mean, and that is the population mean. Put in another way, how well can we assume that this estimated average performs as a measure of average for the population? So can we be certain that this is a good estimated average for the population as a whole? And this is very important when we are going to generalize sample results to the population. Let's look at the shape of the normal distribution and how that depends on the standard deviation. If we have a small standard deviation, we have a distribution equal to A, but if we have a medium standard deviation, it's equal to B, and if we have a large standard deviation, it's more equal to C. And the larger the standard deviation, the lower the peak and the higher the tails. And although the height and the width of the curve may be different, the area under the curve is always the same, it's 100%, and the shape is always symmetrical. And we can describe then the all normal distribution by two quantities: the mean, which is the central tendency, that's the peak, and the standard deviation, which is the variation. And this standard, the standard deviations is important because it goes into calculating what we can call the set scores. And the set scores is that we can convert all single observations in normal distribution to set scores, and we do that by subtracting the mean. We take the value of the single observation and subtract it by the mean, and then divide it by the standard deviation. And that will give us an indication on the distance between a given observation and the mean in the population as such, in the number of standard deviations. for example, if the set score of a man with a height of 175 centimeters are the 175, which is the height of this man, and the mean, which is 181, divided by the standard deviation of 7. So this man, he is 0.86 standard deviation lower than the average man. And why is that? Why is that interesting to know? Well, we can, if you look at the standard deviation, we can see that he has 0.86 standard deviation lower. So he's not deviating that much from the mean. He's within, I mean, 68.2% are within 1 standard deviation from the mean. 95.4 are within 2 standard deviations from the mean. But if you are 1 standard deviation, between 1 standard deviation and 2 standard deviations lower than the mean, it's only 13.6% that are between 1 standard deviation and 2 standard deviation lower than the mean. And that also goes for those who are 1 standard deviation or between 1 standard deviation and 2 standard deviation higher than the mean. It's only 13.6 of all men, for example, who are that high. And it's only 2.1% that are between 2 standard deviation and 3 standard deviation higher, and only 2.1% that are between 2 standard deviation and 3 standard deviation lower than the mean. So in the standard normal distribution, we know exactly the number of share observation located within various intervals counted in standard deviation distances, or so-called set scores. So what can we use this set score for? Well, we can calculate how many men are lower than 175 centimeters. So taking a statistical table for normal distribution, if we have a set score of minus 0.86, we can go in the normal distribution, statistical table for normal distribution, and we find that gives us the value of 0.88 and then 0.06. Then we get this value, and then we take 1 minus the value we found in the statistical table, and we find that we get 0.1949, and that says something that tells us that almost 1 out of 5, or 20% of men, are lower than 175 centimeters. Or you can say it in a different way: 80% of men are 175 centimeters or higher. Okay. That was the e-lecture on normal on probability distribution and the normality distribution. Thank you so much.